Good evening, everyone. This is Unit 4 of IAL Chemistry, June 2016. In the first question, consider the reactions. This is an example of an acid, a carboxylic acid, is reacting with a base or alkali. So the acid-base reaction is known as the neutralization reaction. C is the right answer. For question 2, the formula of a compound present in some vegetable oils is shown below. Which alcohol is produced when this oil is hydrolyzed? Hydrolysis of the ester will give carboxylic acid as well as alcohol. So during hydrolysis, what will happen? Like if it might lose C double bonded with O, or it might lose all of it. So one side will be replaced by H, another one will be replaced by OH. So what we are left with? We are left with CH2O. Here we are left with CH and we are left with CH2O. So H and OH will be attached. So what we get, 1, 2, 3 alcohol groups are there and 3 carbons. So propane, 1, 2, 3 triol. D is the right answer. Next question 3. This question is about the reaction of cyanide with ketone. A student wrote the reaction mechanism. What is the error in the mechanism? A lone pair, we drew an arrow towards the positive center, and then we always draw the arrow from negative to positive. So you can clearly see this arrow, the direction of arrow should be opposite. So the direction of the curly arrow from cyanide ion, that's right. The direction of a curly arrow from hydrogen ion, that's a mistake. It should not be, it is from oxygen with the charge to hydrogen ion. The dipole on atoms of carbonyl is correct. Oxygen is more electronegative, so that's why it is partial negative. And the structure of intermediate which is formed here, that's also correct. The second part, the mechanism for this reaction between cyanide ions and ketone has similarity to mechanism of reaction between hydroxide ion and primary halogen alkane. Both mechanism, what it involve, if we have primary halogen alkane and OH group attack on the primary halogen alkane, this is partial positive negative. So initial step, initiation is attack of initial attack by the nucleophile, because this hydroxide ion or OH ion is attracted towards the carbon partial positive. Same thing is nitrile group is also attracted towards a partial positive. So both have the same initial attack by a nucleophile is similar. That's why A is the right answer. All the following molecules have 4 carbon atoms. Which of these molecules would react with sodium? So alcohol and carboxylic acid can, this is ketone, alcohol, secondary alcohol, alkene and carboxylic acid. So both alcohol and carboxylic acid can react with sodium. Metal react with acid, gives salt and hydrogen. Same as sodium metal react with alcohol to give bubbles, hydrogen is there. So Q and S, C is the right answer for question 4 part A. Next question, which of these molecules would give a positive result? Iodoform. So iodoform result when alkyl group is there next to carbonyl group, this will give a yellow precipitate, a positive iodoform result. So when we check the option, this is secondary alcohol. Secondary alcohol will oxidize to ketone, and then ketone will have this alkyl group next to carbonyl group, and this is already methyl group basically next to carbonyl group. So both will give a positive result, as the secondary alcohol can be oxidized to ketone, and then ketone will give a positive result because there is a methyl group next to carbonyl. So P and Q will give the positive result. Again, C will be the right answer. Next, which of these molecules would give a positive result when tested with 2,4-dinitrophenyl hydrogen? Basically, this is a test for aldehyde or ketone, so we only have aldehyde here, the ketone here. So 2,4-dinitrophenyl hydrogen will give a positive result with P only. So A is the right answer. Which of these molecules would be oxidized by ammonical silver nitrate? So ammonical silver nitrate or a toluene reagent. Basically, this toluene reagent, it will give a positive result with aldehyde. So this is a ketone. Ketone. This one is secondary alcohol. It will oxidize to ketone, but ketone will not give a positive result with toluene reagent. Alkene is there. This cannot be oxidized by this ammonical solution. We can use potassium manganate, so it will result in a formation of diol, but not with toluene reagent. And carboxylic acid cannot be oxidized as well. So the correct answer, none of this. So none of P, Q, R, and S will be oxidized by toluene reagent because that will give a positive result with aldehydes only. Which of these molecules would be reduced by lithium tetrahydrodualuminate 3 in dry ether to form a primary alcohol? So when we check the structures, ketone, we have a ketone, we have secondary alcohol, we have alkene, and we have carboxylic acid. The carboxylic acid will be oxidized back to primary alcohol because primary alcohol oxidized to aldehyde and then aldehyde oxidized to carboxylic acid. So S is a compound which can be reduced to primary form primary alcohol. D is the right answer for this question. Next, which of the following compound would react with phosphorus 5 chloride to form propenyl chloride? So to form a propenyl chloride, we add PCl5. So if we add PCl5 here, so this will result in a formation of CH3, CH2, CH2, Cl, halogen alkane plus POCl3 plus HCl, misty film. So basically, alcohols will give halogen alkane, but we need ethonyl chloride or propenyl chloride. So when we react, add PCl5 here, this will form CH3, CH2, COCl plus POCl3 plus HCl. So we'll observe misty fumes, and this is propenyl chloride. So C is the right answer. D will give butynyl chloride. For question 6, the chromatography is a chemical technique used to analyze a mixture. A components of a mixture will move more quickly through a gas chromatogram if a column has. So if we want them to move quickly, so column should have a lower absorption to the stationary. The component should have a lower absorption to the stationary phase because when lower absorption is there, it can move through the column easily. So C is the right answer. If it is having high molecular mass, it will move slower. If it is having a strong attraction to the stationary phase, again it will move slower and it will have a lower volatility. It cannot be easily vaporized, so It means it will have more particles, more or higher molecular mass or number of the particle, which reduce its mobility. A mixture of four substances was separated using high performance liquid chromatography. The separation was carried out using a polar stationary phase and a non-polar mobile phase. So non-polar mobile phase is there and a polar stationary phase. Which of the four substances least likely to be polar? So the one which is least likely to be a polar, the one which is collected in the short time or move easily through the mixture with a mobile phase. So that's W. So A is the right answer. Polyester or condensation polymers, PET, polyethylene tetraethylate is an example of polyester. Part of this polymer is shown. Which of the following could be a monomer? So to identify the monomer, what we can do, we can take the part out of it, like one side H, another side OH. So if I put OH here and H here, that will be one. And same thing, if I put H, I should put OH here and H here. So it matches with like OH C double bonded with O C4H6, C6H4, and OH C2H4 and OH. So it matches with option C, or C is the right answer. Another polyester PHP is made from a single monomer 3-hydroxybutanoic acid. Which of the following is correct representation of the polymer which is formed by 3-hydroxybutanoic acid? So first we have to draw a monomer, how the 3-hydroxy, and it will be a condensation polymer. So third position we have hydroxy group, and then butanoic acid, so C double bonded with O and OH. So one side we remove H, another side we remove OH, and so it will be CH3, and it's 3-hydroxybutanoic acid. So but means 4 carbons, so I should add another carbon here. So it will be CH2, C double bonded with O. So one side we remove H, another side we remove OH, or one side we remove OH, another side will remove H. So it matches with, you can see here, like if I put H and OH here, so it is third position, is because 1, 2 and 3. Third position we have OH group and carboxylic, so it is 3-hydroxybutanoic acid, so B is the right answer. Buffers are vital in maintenance of relative pH stability in human body. One of these, carbonic acid hydrogen carbonate buffer, is there. Buffer solution when a weak acid mixed with a salt or weak alkali mixed with a salt. So what is the pH? We just have to substitute the value. This is 6.1 plus log the concentration of HCO3 is given, which is 3.51 into 10 to the power minus 4 divided by 3.15 into 10 to the power minus 5, and take a log, will add to 6.1, so it will appear as pH of this 7.14, which is approximately 7.15. The carbonic acid is formed by dissolving carbon dioxide in water. This equilibrium is represented by the following equation. If carbon dioxide is removed, the pH will, so what will happen to the pH for question number 8, part B. So if we remove carbon dioxide, equilibrium will shift towards left hand side. Okay, in the question they mentioned if carbon dioxide is removed from this equilibrium mixture. So if the carbon dioxide is removed from this equilibrium mixture, so amount of CO2 will decrease. If amount of CO2 will decrease, equilibrium will shift towards left hand side, and as the equilibrium is shifted towards left hand side, so amount of H2CO3 will decrease. As the amount of H2CO3 will decrease, because this is in denominator, so this whole factor value will decrease. Sorry, H2CO3 will decrease, so the whole factor value will increase, and when we find the pH will also increase. Because you can see here, H2CO3 gives H plus ion and HCO3 ion. So if the amount of H2CO3 is decreasing, amount of hydrogen ion will decrease. As the amount of hydrogen ion will decrease, the pH will increase. So B is the right answer. As this decreases, shifted the equilibrium towards left hand side. As it shifted the equilibrium towards left hand side, we'll have small quantity of H2CO3. So less hydrogen ions are there in the, if small number of hydrogen ion in the equilibrium mixture, so the pH will increase. Ostwald process is a method which of the following would both decrease the equilibrium yield of nitrogen monoxide. A reversible reaction is there. The forward reaction is exothermic. So we want to decrease the equilibrium yield of nitrogen monoxide. When we check the number of the moles of gas, 9, and here we have 10. So if we increase the pressure, equilibrium will shift towards side where number of moles are less, so we should increase the pressure. And because the forward reaction is exothermic, so to shift the equilibrium toward left hand side, we should increase the temperature as well. So A is the right answer for question 9A. For 9B, for this stage, the catalyst is an alloy of platinum and rhodium. A pressure between 4 to 10 atm and the temperature around 1150 Kelvin are used. Unreacted reactants are recycled. Which one of the following change will affect the value of Kp? Kc or Kp is only affected by temperature. So by changing the temperature, the value of the Kc or Kp will change. Not any other factor will affect the value for equilibrium constant. And equilibrium can be established when solute dissolve in two solvents which are immiscible. Equilibrium constant, known as a partition coefficient, indicate the distribution of a solute between the two solvents. This question is about ammonia dissolved in water and in trichloromethane. Ammonia is more soluble in water than trichloromethane. Density of trichloromethane is 1.48 and water is 1. Which of the following is a correct diagram? First thing, trichloromethane is having a high density as compared to that of water. So trichloromethane should be at the bottom and water should be there at the top. The second thing, the concentration, because it is more soluble in water, so the higher concentration should be there for ammonia and water and less concentration in trichloromethane for ammonia. So C is the right answer. Then at at 25 degree centigrade, when ammonia is dissolved in a mixture of a water and trichloromethane, the equilibrium concentration of ammonia and water is 1.02 and that in trichloromethane is 0.05. What is the value for equilibrium constant? Equilibrium constant is always the product divided by the reactant. So in the product it is 1.02 and the reactant it is 0.045. So when we divide, it will come out as D. So D is the right answer. And about this question about carbonic acid, as you can see, carbonic acid is formed by dissolving carbon dioxide in water, and this equilibrium is represented by the following equation. If the carbon dioxide is removed from equilibrium mixture, so amount of carbonic acid will decrease. As the amount of carbonic acid will decrease, the concentration of the carbonic acid will decrease. So amount of hydrogen ion in the solution will also decrease, which will increase the pH. That's why B was a right answer. So this was Unit 4 from June 2016, IAL Chemistry.